Let's see another example. Here we shall talk about the low liquid level protection on the water side. Recall here that the main cause shall be the failure of the control loop LIC01. This may be due to some false reading from the transmitter, for example, or it can be due to the failure of the control system, or due to the mechanical failure of LV01. And the failure here shall be, of course, in the open position. So here, the frequency of the control loop shall be taken as once per 10 years, which is 0.1, same as the previous example. We are here having cell 2 level shutdown, so this shall consider a level transmitter of cell 2, logic solver of cell 3, and shutdown valve of cell 3. So the overall cell rating here shall be the component with the lowest cell rating, which is the transmitter that is having cell 2 versus cell 3 for the logic solver and the shutdown valve. So here the cell rating shall be cell 2 for the whole loop. The probability of failure on demand of cell 2 protection is 0.01, which is equivalent to once per 100 times. So the frequency here of the event shall be the multiplication of 0.1 times 0.01, which is 0.001, or once per 1000 years. Remember that when we say once per 1000 years, this doesn't mean that it shall happen after 1000 years. It can happen at any time, but it's an indication of the probability of the consequence occurring. What about the severity? The issue here is that the consequence can be huge. This is because we are talking about gas blow-by case where the liquid level falls and the vessel is drained from liquid. Here, the pressurized gas shall start to go to the water treatment system, which is usually operating at atmospheric pressure and cannot handle any pressure. This shall lead to massive damage and may lead to an explosion, which at the end shall lead to multiple fatalities in the area if the area is occupied. It may also lead to a major gas release and to tens of millions of dollars if we are talking about cost. So here the severity shall be catastrophic, which is 5. Now let's check out the risk reduction matrix. For a frequency of 0.001 per year, or in other words, once per 1000 years, and a catastrophic consequence, the risk reduction factor shall be 2. So here we should either decrease the frequency or the severity. Maybe it will be difficult to reduce the occupancy if the area needs some monitoring or maintenance, so we shall go with reducing the frequency. To reach a risk reduction factor from 2 to 0, we shall add more protection layers. This can be either by adding a PSV on the water line or at the water treatment system, and this shall solve the issue. Or if installing a PSV is not applicable here, we can increase the cell rating of our SIF function, which closes the shutdown valve. Recall that we already had the shutdown system and the SDV at cell 3. Only the level transmitter had a cell rating of 2. So in order to increase the cell rating of the SIF function, we shall need at least 2 transmitters with cell 2. It's very rare to consider a level transmitter or any transmitter with cell 3. That's why in this case voting would be the alternative. So we can consider 2 level transmitters with cell 2. So here the shutdown valve shall close if it receives low level reading from one of the 2 transmitters. This is called, as I said, 1 out of 2 voting. Sometimes we may even use 3 transmitters so that the action is triggered if it received a shutdown reading from 2 of the 3 transmitters, and this shall be called 2 out of 3 voting. So here 1 out of 2 voting may be enough, and we shall add another level transmitter. This way our SIF function shall now has a cell rating of cell 3. But still, the risk reduction factor will be 1 as we reduced the frequency from 0.001 to 0.0001, which is equivalent to 1 at a catastrophic consequence. So we can add an additional alarm to warn the operator. A pressure alarm on the water line may be recommended as pressure rise may happen too quickly. That's why level alarm is preferred in this case. Now the risk reduction factor will be reduced from 1 to 0. Here we should notice that each level alarm shall need 2 additional nozzles in the vessel. This is because we cannot rely on a single bridle for more than one level instrument if these instruments are considered as independent protection layers. If the bridle having more than one level instrument was plugged, all the instruments in the bridle will fail. That's why we should consider a separate bridle for each level instrument that is considered as an independent protection layer. If it is a field instrument, then it can be mounted on the same bridle. So we are having 2 nozzles for level control and level glass. Level glass, of course, won't be a protection layer as it is a field device, and all field devices cannot be considered as a safeguard in HAZOP or as a protection layer in cell assessment. We are having 2 separate nozzles for LT02. We shall add another level transmitter for shutdown, so it shall need another 2 nozzles. We shall add also another level transmitter giving another alarm, so we shall add 2 other nozzles. So here we can see that there are too many nozzles. That's why the P&ID designer should check out and evaluate the best solution that reduces the risk reduction factor, whether it was adding a PSV or increasing the cell rating with an additional alarm.